All right, what we're going to do now is do special factorings, and they're perfect squares or difference of squares. And so you need to know your squares, and they are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and we can keep going on to 121 and 144, and they keep going, 13 times 13, and keep going. But there's our main ones. So we're looking for these numbers when we have a problem. In this case, this trinomial has a 64, which is a perfect square if you look up here. And we need to make sure the first one is a perfect square. That means it's an even exponent, or also has a perfect square, which is 1. So when we have that, we can then split this apart by going 2 factors, and the x squared splits to the x. The 64 splits to the 8 because that's the perfect square of it. And then because the middle term is a plus, both of these will be plus signs. So that's what's called a perfect square trinomial. Now the difference of squares is when you don't have a trinomial, but you have a binomial, or 2 terms. And we always have to make it equal to 0. So I'm going to switch this by minusing the 64 to give me equal to 0. Now I have 2, and I have a difference, and I have a perfect square. So I'm going to split it into 2 parts again, x and the x, and the 8 and the 8. But this time, instead of a plus, it'll be a plus and a minus. A plus and a minus, when I multiply them, give me a negative. That's why they have to be a plus and a minus. So let's look at some different trinomials. So here's another trinomial. The first term is a 4, which is a perfect square. The last term is a 9, which is also a perfect square. So I can split this apart by splitting the first term into the first spots. So 2 and the x, and then the 9 is a 3 and a 3. Now the middle term is a subtraction sign. So that means I'm going to have subtraction in both of these. Now let's look at our next problem. Our next problem, the problem is that we have an x here, and that x can be factored out because x is not a perfect square. It has to have an even exponent on the ends, and we've had that before, an x squared, an x squared, an x squared, but we have an x here. So I'm going to factor out the x, which gives me an 81x squared minus 9 equals 0. And then we can factor just what's in the parentheses, which is a perfect square. So I still have my x, but I'm going to go 2 factors. I'm going to split the 81 and the x, so it's 9x, and split the 9, which is 3 and 3. And because it's a difference, I have a plus and a minus. So I have my factor with the x included after I do my greatest common factor. So sometimes you have to do that before you can do the difference of squares or the perfect squares. So let's look at our next problem. Same example. 3 is not a perfect square, and a is not a perfect square. So if I factor that out, 3a, I get 2a minus 1 equals 0. Now, the 2 is not a perfect square, neither is a, so I can't do anything further, and so this would be my answer. So keep in mind that sometimes you don't have perfect squares. All right, let's talk about trinomials. I call it a trinomial riddle. And what I mean by that is we're looking at the last term, and it's not a perfect square, so we can't use the perfect square method. 20 is not a perfect square. So I want to know what numbers multiply to give me 20. So I'm going to do a little chart, and I'm going to go 20. What numbers multiply to give me 20? Like 20 and 1, and 4 and 5, and 10 and 2, and a negative 4 and a negative 5 also give me a positive 20, and a negative 10, and a negative 2, and a negative 20, and a negative 1. And then if I add them up, I get 21, 20 plus 1, and 4 plus 5 is 9, and 10 plus 2 is 12. And this is a negative 9, and a negative 12, and a negative 21. But what I'm looking for is this middle term. That middle term, 9. So I'm looking at this as my answer, because it's whatever adds up to that middle term, but multiplies give me the 20. So my answer would be x plus the 4 and x plus the 5. And there's how you do a trinomial when they're not perfect squares. So let's look at our next example. I have 30, so I'm going to make a little chart. And 30, and what I want to know, what multiplies give me 30? Like 30 and 1, negative 30 and negative 1. 6 and 5. Negative 6, negative 5, and 15 and 2, and negative 15, negative 2. So I'm looking now for what adds up to 11. Well, if this is 31, negative 31, this is 11, this is a negative 11. Well, I get there right here. So my factors then are x plus 6 and x plus 5. Now, some of you can probably look. Now, here's the issue. I need a negative 11, my fault. And so I actually circled the wrong one. So let me erase this, and erase this one, and erase this one. It's the negative 11. It's the negative 11 that I need. So it should be a minus 6 and a minus 5. Because a minus 6 and a minus 5 do multiply to give me positive 30, but I need a negative 11. So this is the correct factors. And you see that through the chart. All right, so let's do our last and final problem, where I'm looking for a negative 21, and I want to add up to a negative 4. So I'm multiplying. So now I'm going to have a negative 7 and a positive 3. And let's say a positive 7 and a negative 3, and a negative 21 and a positive 1, and a positive 21 and a negative 1. I don't think there's any other numbers, so if I do my adding, I get a negative 4 and a positive 4 and a negative 20 and a positive 20. Well, we're looking for negative 4, so here is our factors. So my factors will be x minus 7 and x plus 3. Now, you don't need to write the chart out if you can look at the number and tell what's multiplied and adding up to the middle term.